Okay, next question 6. On the dartboard, the center circle has a diameter of 2 inches. What is the probability of hitting the shaded ring? Round to the nearest hundredth. Now, don't be fooled. They're telling you the center circle has a diameter of 2 inches. That's this little circle in here, which means if it has a diameter of 2, means it has a radius of 1, okay? Please be careful. We have a radius here of 1. Now, if that's true, that means the center circle is diameter 2. What is the probability of hitting the shaded ring? So out of this entire board, so the whole board, what is the probability that it would land in the shaded space? The shaded circle. Let's start off with finding the area of the whole board. Area is pi r squared, right? So we need to know the radius of this entire circle. The entire circle has this entire radius from dead center all the way to the end. So that's 5 inches plus another 5 inches plus 1 inch. So that entire board has an radius of 11. So we know that the entire area is 121 pi. But now we want the area of the shaded space. So the shaded space is going to be the area of this circle minus the area of the little circle in the center. So we want the area of the blue circle squared, the radius of the blue circle squared minus the area of the green circles. The area of the green circle. So that radius squared. Now the blue radius is not just 5, it's 5 plus 1. So that means that radius is 6. And then they already told us that the radius of the inner circle, the diameter of the inner circle, they told us was 2, which means the radius of that one is 1. So 6 squared is, we have 36 pi minus 1 pi. So that means the area of the shaded circle is going to be 35 pi. And if I do 35 pi divided by 121 pi, I find that I have a probability of 0.289256, etc., which brings me to a probability of 0.29. Number 7. This is similar to the ones at the top. A point is chosen randomly on JM. Find the probability that the point is on JK or JL. So on JK or JL, that means I want it to land within this space or within this space. So here's kind of a trick question. It's not doubling the probability of it landing within JK. It's kind of setting it up as a trick question because that really means as long as it lands somewhere within JL, it satisfies this, right? Because if it lands within that whole space, it did land within JK or it landed within JL. So here's the thing. What I'm really looking at is 4 out of the total of 2 plus 2 plus 1.5. The entire space was 5.5, but it could land anywhere within this worth of 4. So 4 divided by 5.5 gives me 0.72727272, which gives me a probability of 0.73. Almost 3/4 of a probability. Almost a 75% probability. Okay, last question, right? Yep, last question, number 8. What is the probability that a coin randomly tossed into the rectangular fountain, this 9x5 space, lands on one of the square islands? The islands are all the same size. So, out of this entire rectangular space, What is the probability that it would land within one of the 3 islands? So first, the area of the entire space that it could land within is a 9 by 5 space. So we have a 45 square foot space that it is going to land within. Out of that 45 square foot space, it has 3 islands that it can land on that are squares with dimensions of 1.5 and 1.5, right? All the sides are congruent on all of these. So the area of each island is 1.5 times 1.5. So each island has an area of 2.25 square feet, but there are 3 islands worth 2.25 square feet. So that means it has a total of 6.75 square feet that it could possibly land in to satisfy this situation. So 6.75 divided by 45 gives me a probability of exactly 0.15. Okay, if you have questions, please let me know. And yeah, let me know if you have questions on anything that we have covered, because your next step is your test. Actually, your quiz and then your test. Bye, guys.